Alright, so here we are with Chapter 5, problem number 25, and it reads, Bonnie and Clyde are sliding a 300-kilogram bank safe across the floor to their getaway car. The safe slides with a constant speed if Clyde pushes from behind with 385 newtons of force, while Bonnie pulls forward on a rope with 350 newtons of force. What is the safe's coefficient of kinetic friction on the bank floor? So you can see already I've drawn the free body diagram for the safe, and you can see that Bonnie and Clyde are both applying force in the same direction, even though one is pulling from one side and the other is pushing from the other side. So what we want to do now that we've got the free body diagram is just write down our givens. And in this case, we know that Bonnie is going to push with a force of 350 newtons. Clyde's going to push with 385 newtons. The mass of the safe is 300 kilograms. And they tell us it's moving at constant velocity, so the horizontal acceleration is equal to 0 meters per second. And they would like us to find out what is the coefficient of kinetic friction. So I'm going to start in the x direction with Newton's second law. So the sum of the forces in the x direction equal ma sub x. And I'm going to write down what I have. I've got the force of Clyde plus the force of Bonnie. And then I have the force of kinetic friction opposing me. And that's all equal to 0 because the acceleration in the x direction is also equal to 0. So plugging in what I know, I've got 385 plus 350 is equal to then the coefficient of kinetic friction times the normal force. So we don't know the normal force, but we can find it if we look at our free body diagram. We see that the normal force can be found in the y direction. So we just do the same here. The sum of the forces in the y direction is equal to ma sub y, and it's not accelerating the y direction, so that becomes 0. So we get the normal force minus the weight is equal to 0, or the normal force is equal to now the weight, which is just m times g, so it's 300 times 10, and the normal force is then equal to 3,000 newtons. And I can plug that back in right here. So I get 735 is equal to 3,000 times mu sub k. We find that the coefficient of kinetic friction for this bank safe is 0.25. That's it.